Hello all. In this video, we'll be discussing in brief on following concepts like object-oriented concepts on Python, the class, method, inheritance, the object creation, polymorphism, overriding, interface with one or two examples for each. Here I assume that you'll be having sufficient knowledge on object-oriented concept. In this video we'll be seeing how this can be implemented, how this can be uh, the program can be written in Python. As you all know, class, it is a user defined prototype for an object that defines a set of attributes that characterize any object of the class. Like book is a class, it is a template, it's a blueprint. The book has got so many attributes like ISBN, the title, authors, the price, edition, publication, publisher. These are all the attributes. When I take one particular textbook or one particular book, all these informations are particular to that book. Like the book has got its own price, or it is published by a publisher, that book is of this edition, etc. So to create that real-time object, real-time instance, we need a template. That template is called class. In Python, keyword class is required to define a class. In this example, you can see the class is a keyword. The class which I am going to create is employee, as I don't have any other statements. So I can end that class with the pass. You can include any documentation statements, documentation string for future reference. The object creation, that process is called instantiation. The class object is like a factory for creating objects. To create uh, that object called employee, this statement is used. Here, this is a reference variable and this is the class name. When I am trying to print the value of E, that is that reference variable, that reference ID will be some reference information will be displayed. Okay. After the instantiation, that object resides in the memory. Object gets the memory space. The class does not get anything. Only that object or the instant of the class will be getting the memory space. Now, how to define attributes? How to access these for processing purposes? Dot operator is used to access the attribute. You can see here E is my instance that was created just before. Name, employee ID, department, salary are the attributes. I can set this in the main program. I need not give this in the class like Java or C++. I can straight away give that in the main program just like an assignment statement. You can see the dot is required, which will separate the attribute and the class variable, class reference variable. If I give e dot name, that is an attribute. If I simply give name, it is a variable. The right hand side is the value. So as you can see, this is a string. So e dot name is of type string. E dot employee ID is integer or number because right hand side is a number. Again, e dot department is a string, e dot salary, that attribute is a number. So dot is required, dot operator is required. With that you can access different attributes. I can directly use that attribute e dot name in the print statement. It will print the stored value. The functions. It is a block of code which only runs when it is called. You all know how to create a function. Sometimes function returns a value also. Function takes the argument. Sometimes without the argument also you can call the function. Function has got its own name. So it is optional to return the value. May or may not return the value. Later in the part, we'll be seeing two different types of the function. Those are pure function and modifiers. Now we'll see the later version of the function. For that employee class, I have to display all the information as per my requirement. A customized way of displaying the data. This function takes that instant, that object as an argument. E dot name, E dot employee ID, E dot salary, dot department are used to access all the attributes. I'll be displaying these with proper headings just for the beautification purpose. I'm writing here my own way, my own function. This is another way of writing the function. The, the special, the percentage things are shown here. That what is that percent D, percent DS, percent C, F, all these things just to display these information as for that particular data types. You need not use int or str in this print statement. Here in Python, these objects are mutable. That means when you modify that inside a class, inside a method or inside a function, that is reflected outside in the calling object. That is the meaning of the mutation. Objects are mutable. You can see here one example. For that employee, I would like to give the hike. That hike is in terms of percentage. I'm calling this function hike underscore salary by passing two arguments. One is that object E, other one is that how much I have to give the hike. So salary is recomputed. E dot salary equal to E dot salary into 1 plus hike by 100 because that is in the percentage. This is how the function is called hike underscore salary. That E is that object. I assume that you created already, and hike as here you are reading from the keyboard. By default that is in the form of string. You have to convert that into integer. Suppose before calling this function the salary value is say 1000 rupees, 1000, and I'm going to give 10% hike. Hike value is 10%. The original salary, old salary is 1000 rupees. As object I'm passing here, I'm modifying the attribute. It is getting reflected. So the new salary will be 1000 plus 10% of that 1100. So this is how the meaning of mutation. The object state gets changed, gets modified. So this is a feature of Python where object gets mutable. One of the important things that comes one or other place Python, that is the assignment, and different versions of copy, shallow copy and the deep copy. Here, for example purpose, I'll be taking employee of class which has got two fields. One is the salary field, other one is this employee class has got one field as salary. The other field is the date of joining. The date of joining is again a class which has got one of the member called day. So the class EMP has got another class. The object of EMP has got another attribute which is of type a class called date. Just for simplicity, here I am going to take only two fields. One is the salary, other one is the class date of joining. Now we'll see what is assignment, what is the effect of that, what is these two types of copy, shallow copy and the deep copy. The first one, assignment. Here E1 is a new variable that I am going to take, which is assigned to value, that is E. E is assigned to E1. This you have seen in different languages, just an assignment. How this is different. Here when you perform assignment operation, it does not allocate another new memory location. For the same memory location, another name is given. E is stored in some memory location which has got address that can be retrieved using ID. Say this is the ID of this E. Because of this assignment statement, E1 is also referring to E. So it does not take another memory space. Both refers to the same thing. When I say both refers to the same thing, whenever you modify attribute of E or E1, it is reflected in other also. You can see that here in this example, I'm modifying the value of salary attribute to 200. Then I'm modifying salary attribute of E to 100. As both are same, the latest declaration, that is E dot salary, is in effect. Similarly, I'm going to set day field of date of joining to 11. Then I'm modifying that date field in E1 to 12. As both are same, E and E1 are same, this is in effect. The latest one is in effect. When I'm trying to print the salary field of E and E1, I'll be getting the latest one. That latest one is this field, this one. Similarly, the latest date in that date of joining is 12. The latest one is this one. So this is quite dangerous. Knowingly or unknowingly, when you use assignment statement, and knowingly or unknowingly when you modify it, other is also getting modified. So this is not advisable one to for use assignment statement, because both refers to same memory location. There is a mutation. When you modify it, it is reflected in the other also. So what is the solution for this? You can go for copy. This is just like ordinary copy. To use that copy, use library, import library, copy.copy. This function, this method can be used. This method is used. Here, I'm going to create a copy of E in E2. Now, E and E2 are separate object. You can see that here in ID. Both are of different ID. When I'm trying to print the value of ID, you can see here, you get two different IDs. Now, how this is different over the previous one? As usual, I'll be setting salary values to both of the object. In the same way, date to both the object. E2.salary say 300, E2.salary, E.salary is 400. In the same way, date I'm going to set for E to 10, 12 for E2. When I'm trying to print it, you can see here, you can see that is not reflected in the other object. Entirely different. 400 and 300 are entirely different because both are different object. But you can see here the inner embedded object are untouched. That shares a common memory location. That is why as salary is not the object, that attribute is not object type, it is just a ordinary variable, ordinary things. Here date of joining is an object. So both E2 and E shares a common memory location for DOG. So whatever the modification is done, it is reflected in the both object. So latest modification is this one, so we'll be getting 12. Again, this is a problem. So you can use this copy, provided you should not have the embedded object as an attribute. So what is the solution? The solution is to safeguard that embedded object, you can use deep copy. Again, use the same import copy statement, but use the method deep copy. I'm going to create the copy of E, that is deeper copy of E in E3. So as before, both are of different object. Like earlier, I'm setting salary and date with the different values. When I'm trying to print it, there is no difference here. Salary, like before, both are different. As you can see here, date of joining, both are safeguarded. Both are safeguarded. So this is the best way whenever you want to copy the objects which has got embedded object as an attribute. So this is a divisible one. This is not recommended. This, it is left to you. Whenever there is no embedded object, this is okay. Whenever there's embedded object, better to go for deep copy version. Now in this, here in this slide we'll be seeing for a particular object how to retrieve an attribute, just to check whether an attribute is there or not, to add new attribute, to remove the attribute. So there are four functions. One function is get attribute. It requires minimum mandatory two parameters. One is that object, other one is the name of the attribute. This is the string. Example, same class, employee class. I'll be using salary. I'll be retrieving the salary attribute using get statement. So e dot salary 600 is set to the attribute salary. Get attribute will retrieve the value, the data associated with that attribute e salary. So 600 is stored, 600 is retrieved. Last assigned value is returned. The other one has attribute. It takes two parameters. One is that object, other one is that string form of the name. This will return true or false. If this attribute is associated with this object, returns true, otherwise false. Here, already I set the attribute salary. I'm checking whether salary is associated with E or not. Here it is true because salary is associated with E. The third is I'm going to set a new attribute. That attribute is name, its value is here. This name should be in the form of string. I'm going to set for the employee gender attribute. I'm going to set M to the gender attribute. So I'll be getting the gender using get, the M is retrieved. I don't want that gender, I have to delete it. I can use delete attribute which will delete that attribute. Gender attribute is going to delete. Just to confirm whether it is really removed or not, deleted or not, I can use has attribute. The first parameter is object, the second is object name, the attribute name. So here you are deleted, so returns false. These are the different terminology that you use. One is the data member, the other is instance variable, instance, instantiation, the method, and the object. The first one is the constructor. Here in Python, uh, the constructor body is created using two underscore init to underscore characters. So that init stands for initialization. That initialization happens when you invoke the constructor. Constructor purpose is to construct the object. It's also to initialize the values to the attributes. Here I'll be taking the same employee class having four different attributes: name, employee ID, department and salary. This is the constructor. Like it looks like a function. Def is required, underscore underscore init and underscore underscore the parameter self. As this is a part of the class, one parameter that is required, one argument that you have to pass is the self. So this is the default constructor. Default constructor. Here I'm going to initialize the value xyz 200 ds 200 to these attributes: name, employee ID, department and salary. One more method is also introduced here. Purpose of that method is to display all these attributes in the native format. For that it takes one argument, that is self. How to access those attributes: self dot name, self dot employee ID, self dot salary, self dot department. Instead of object name, here you are using that self object, this object, like in Java. I'm going to invoke that the main body. This is optional. This is another way of calling a statement. These are all not required. The object creation, calling that method print underscore details 1. You can see here this is called. This is that self, that object. This another variation in the constructor is parameterized constructor. The method which I already introduced and the parameterized method. Till here you have seen. Now I'm going to introduce one more constructor which takes the parameters like name, ID, department and salary. I'm going to pass it from the outside. So whenever you add one more constructor, whenever you add overloaded constructor, the old one will be removed. The latest one in the code part, which is the latest one. This is the latest one. This is in effect. So no more exist this particular thing. This will not be available. Only this is because we have got two versions. The latest version is this one. This is in effect. I'm going to assign name to the name field, ID to the ID attribute, department to the department attribute, salary to the salary attribute. One special observation that we can have here from the previous is this parameterized constructor. In the same way, the parameterized method. In the previous case, we have sent that self, we have used self, that is that this only. Here I am going to display some other object details here. Okay, I'm invoking this from the self, but I'm going to print the other object here. E dot name, that's the difference, nothing else. How to call that? E is my employee, that E is the first employee, E1 is the second employee. This is as usual. This will be called E dot print details. Now I'm going to print E1 from E. Printing, displaying E1 details from E1. How to invoke it? E dot print details. The parameter here, E, function. In the previous told, there are two different types of functions. One is the pure function, other one is the modifiers or modifier function. The pure function which returns a value, it can return a value, it can return even a void also, but it won't modify the attributes. If a function that does not modify the attribute, such functions are called pure functions. Which modifies, which mutates the attributes are called modifiers. It's just like getter and setter method in Java. First is the pure function, other one is the modifier. If I write the function inside a class, then that is called method. There are two types of methods, pure methods and modifier methods. Here it is given the coding is done outside the class. That is why these are called function. The colored one is a new thing. One is a modifier. I'm going to print other object. I'm going to print the details of an object. This is a function. I'm going to pass e. I'm retrieving the value here e dot name, e dot salary, e dot id, e dot department. There is no question of modification. It doesn't do any modification. It doesn't do any modification. So these functions are called pure functions. Okay. The other one, I'm going to increase the salary. I'm passing the object. I'm modifying the attribute salary. These functions are called modifiers. Modifiers. The salary is recomputed. Salary is revised. It is stored here. I need not return because objects when you pass it's a mutable. So these functions are called modifiers. These are called pure functions. We'll have some the functions of the method has got its own difference. The methods as I told are defined inside the class. Functions are given outside the class. Methods are associated with the objects of the class they belong to. These are not associated with any object. Directly we can call here. The function is called directly. Here method is invoked which is associated with the object. Method is associated with the object. Function is called directly. A method is called on object. We cannot invoke it just by its name. On object it is called. On object it is called. So this is function, this is method. You cannot call this method without this e dot. That is why it is on object. Functions operate on the data you pass. So no need of any object and all. You can pass object as an argument. Methods are dependent on the class. So this can be called with the object. When you don't create the object, there is no question of calling it. But function can be called without the object. You need not create the object. Method required to have a self as an argument. That is the first argument here. You can see here method. In this method, no, the first argument is a self. But in function, that argument is not required. Self is not required. So these are some observations. The difference between method and function. Sometime we need to return some string. That return string I should be able to print it directly using print statement. For that we have got string. This is similar to toString in Java. Underscore underscore str underscore underscore. This method. How I can use it here. I'm going to display the details in the string format. I'm going to form my own the beautiful string combining all these informations like name, ID, department, salary. I'm forming a string. Then I'm going to return it. So once the string is returned, I can directly call print statement. This is how the str works. Print of E1 as str is defined, str returns a string. That string is that string is displayed using print. So this is an advantage of str method. This is similar to toString in Java. Polymorphism. The function which takes any types of parameters. Functions which takes any type of parameter. Here one example which I can take, the palindrome that comes into picture. Palindromes can be there. Palindromes can be decided for the given string or given number. When you reverse the string, if original string and the reverse strings are same, we can say that the string is palindrome string. The same way, when you reverse a number and the original number and reverse numbers are same, we can say that the number is a palindrome number. I'll be using that concept to show this polymorphism. I'm having now two classes, one for testing the palindrome for the string, other one is for the number. I'm checking palindrome whether it is a palindrome or not. I'm using slicing method to reverse the string. I'm comparing that with the original string. If same returns true, if not same returns false. I'm using this concept repeated division and extracting the remind, placing that in the other end. Then I'm comparing that reverse number with the original number. If same, returning true, otherwise false. This is, you studied that somewhere else. Now, how the polymorphism can be demonstrated? I'm using one function which calls the palindrome, either string palindrome or number palindrome, which returns and prints true or false. Say, my string is rider, my number is 121. Okay, now I'm creating the object of palindrome string or palindrome number, setting the parameter s dot str rider s n dot number 121. I'm calling this function, passing object s. The object is f. As the object is of type this class, is palindrome of this is called. Is palindrome of this class is called. In the second case, n, object n is passed. Object n, that is of type of class palindrome number. The method associated with that class is this one. This is called. So this is an example for polymorphism. Interface and how that can be implemented. One of the goal of object-oriented design is to make a software more maintainable. You will be giving a function signature. It is a duty of the developer to give their own code. The person who is giving these things, say design team, the developer, they got a freedom to give their own code. This can be easily implemented using interface. To implement that, we have to use the library, that is import abc. I'm going to create an interface class, my interface name. This is the statement that is required, abc.abc. This tells that you are using interfacing, you are creating the interface. In that, one abstract method is used. That abstract method is print underscore details. Okay. So whichever the class which implements this interface has to give the declaration, has to give the implementation for this particular method. Otherwise, it gives error. Now, small modification compared to the previous one. The class employee is going to implement the interface, my interface. So this should be given inside the bracket. This observation you have to make. The my interface is going to implement it by employee. Rest of the things are same. The thing that you have to note, this particular method should be defined here. Here it is abstract, here it is concrete. The purpose is same. If this method is not given, this gives error, because this class here in the declaration you can see it is implementing the interface, but the abstract method is defined, not given, so gives error. Rest of the things are same. The calling process, everything same. Inheritance. Inheritance is the ability to define a new class. You are going to derive new class. You are extending the class. The class which is derived is called child class. The class from which a class is derived is called parent class. It inherits some more features. That is why that process is called inheritance. We'll see with a small example. All employees are person. There is a class called a person class, which has got a method display. Right now I don't have any code. I'm raising that exception. Now the derivation extending happens here. employee class is derived from person, it should be given inside the bracket, just like before. In the previous case, abstract that interface is given as a parameter. Here base class is given as a parameter, rest of the things are same. Now my own way of derivation, here this is one version, this is another version. You can give any statement here. This particular developer using this line of code for this display, so there is a freedom for the developer, they can give that in different way. Now in addition to the base feature, your base class has got no attributes, but derived class has got two attributes. One is that name field, other one is that id attribute. Additional things comes here. Inherited, employees inherited from person, new features are added. This is the interface. This is an example. Interface can be used to develop a code for finding the area of a triangle, area of a circle, area of a rectangle. With this, we have completed, in brief, various object-oriented features that are in Python. Thank you.